The world economic recession has touched every walk of our lives. Youngsters are looking towards the village. They are in search of profitable agri-based activities. These educated, young and energetic people can understand and implement any technical project. Beekeeping, mushroom cultivation, etc. are the best subsidiary activities for such enterprising young farmers. This agriculture film explains everything about edible mushroom production. Till now, many people have had bitter experiences with rabbit, emu, mushroom, etc. Some private consultants misled and exploited innocent people with attractive ads on their activities. But the KVKs of Agriculture Universities, Department of Horticulture and IIHR Bengaluru have provided proper and reliable training on mushroom production. Despite all these efforts, the farmers failed after one or two successful crops of mushroom. It is difficult to establish the market without the continuity in the production. On the contrary, mushroom cultivation is an easy job. It needs very less investment and space. Let us study the reasons for the failure first before going into the details of mushroom cultivation. The hotels used canned button mushrooms for their regular preparations, but its cultivation is difficult for common farmers. If the fresh oyster mushroom is introduced and supplied continuously, no doubt the hotels will accept it. Hopcoms sells the fresh oyster mushrooms through its outlets. It can be dried like this or processed into pickle. The Department of Horticulture produces the spawn in its laboratories. The only shortage is the successful mushroom farmer. The first problem of mushroom cultivation is the continuous availability of contamination-free spawn of required species. Department labs are discontinuous due to lack of regular demand. The mushroom crop fails after one or two successful crops. Contamination with unwanted microorganisms is the main reason for this failure. Mushroom is a fungus. Likewise, there are huge numbers of fungi in the nature. They also develop with this mushroom fungus and spoil the crop. This is a technical problem. If the educated youth are given proper training, solution is not so difficult. Mushroom is not a non-veg food. It is a tasty vegetable with 20 to 30% of protein. It is a complete food with all nutrients and vitamins. Even it has some medicinal properties and hence is good for blood pressure, diabetes, obesity and heart patients. Scientifically, mushroom is a fungus belonging to the plant kingdom. There are about 20,000 species of mushrooms, of which 2,000 species are edible. Out of this, 20 types are being cultivated. Three types of edible mushrooms are commonly cultivated in India. They are white button, milky, and oyster mushrooms. Cultivation of white button and milky mushrooms is a little bit complicated. Oyster mushroom is popular among common farmers. Hence, this film explains its detailed cultivation methods. In Himachal Pradesh, mushroom production is a popular commercial enterprise. They grow button mushroom on large scale in the open during the winter. They go for oyster in the rainy season and milky during the summers. In Karnataka, mushroom production is not yet tried systematically. Recently, one more costly mushroom called shiitake is being introduced for cultivation. First, let us study the cultivation of white button mushroom in brief. Botanically, it is Agaricus bisporus. This is a fleshy and tasty mushroom, which has got highest demand. But the cultivation is a bit complicated and specific. First step is the preparation of compost, Paddy or wheat straw is mixed with rice bran, neem cake, poultry manure, fertilizer, gypsum, etc. to prepare this compost. Then it is pasteurized to kill the unwanted microorganisms. In the next step, the spawn is mixed with the compost and filled in poly bags. Fungal mycelium covers the substrate within 15 to 20 days. Then open the bag and put the pasteurized casing material. Sandy soil is mixed with old manure and coir dust, etc. to prepare this casing material. The fruiting bodies grow only at the specific temperature of 16 to 18 degrees centigrade and relative humidity of 80 to 85%. Hence, the air conditioner is compulsory. The pinheads of the mushroom appear within 15 to 20 days after putting the casing layer. It matures in a week's time. Then pluck the mushrooms individually and clean them. Pack them in perforated poly bag and send them to the market. This technology needs heavy investment and is difficult for the common farmer. Hence, this button mushroom cultivation is rarely seen in Karnataka. Now, let us study the cultivation method of milky mushrooms in brief. Botanically, it is Calocybe indica. This species is well suited for the higher temperature of 30 to 35 degrees centigrade. The fruiting body is an attractive milky white color, like this, and does not fade even after plucking. It keeps good for 3 to 4 days in the open and for 2 weeks in a refrigerator. It is becoming popular because of its taste and color. The initial steps of cultivation are similar to the oyster mushroom. Chaff the paddy straw, soak it in water and pasteurize. Fill the straw in poly bag and put the spawn. Mycelium covers the substrate within 20 to 25 days. Then open the bag and put the pasteurized casing material. Maintain the required moisture in the bag by sprinkling water. Mushroom fruiting bodies grow within 15 to 20 days. It is ready for picking in 8 to 10 days. Mushroom consultants have given a lot of publicity for this milky mushroom, but is not yet successful at growers level. Crop cycle needs 3 months. This is more sensitive than oyster fungus. Hence, the problem of contamination is more. Since it needs higher temperature, cultivation is not possible during rainy season and winter. It is cultivated in small poly bags due to the requirement of casing. Hence, the cylinder system is not possible for large-scale production. Now we have come to the main part of the film, the oyster mushroom cultivation. This is well known for our farmers. Pleurotus florida, Pleurotus austratus, Pleurotus sager-kaju are the common species. The new introduction is Hypsizygus ulmaris. This is Pleurotus florida. It has the attractive white color, but the shelf life is only 1 day. This is Pleurotus sager-kaju. It has a light black color, but the yield and shelf life is more. This is Hypsizygus ulmaris species. It gives higher yield and better taste than all the other oyster species. Keeps good for 3 days in open and for 1 week in the refrigerator at 8 degrees centigrade. Cultivation of these oyster species is simple and needs very less investment. 25 to 30 degrees centigrade temperature and 80% relative humidity are good. If the temperature exceeds 35 degrees centigrade, yield comes down. Comparatively, the contamination problem is less in oyster mushrooms. Now let us go through in detail. In all mushrooms, the gills on the lower side of the cap produce the powder-like spores, but it cannot be collected for cultivation. Hence, the fungal mycelium is grown on sorghum grains in the laboratory. This is used for further cultivation and is called spawn. The fungus is grown on organic substrates like paddy straw to get the crop of its fruiting body, the mushroom. Spawn production is not possible for the common farmers and is not required also. One spawn lab can supply the spawn for hundreds of farmers. This is a highly technical job which needs basic scientific knowledge and technical training. This is laminar airflow chamber used in the laboratories for the inoculation of microorganisms into the growth medium. For large-scale production of spawn, this is essential. But look at this simple setup. A box with a UV lamp is used for the purpose successfully. He works with all accuracy to produce the spawn without any contamination. Bring the mother culture of the fungus of required species from the laboratories like IIHR and keep it in the refrigerator. First and second generation spawn is prepared with this culture. Then, these are used for the production of the commercial spawn. This is used only for cropping. If this commercial spawn is multiplied, the yield comes down. Bring the clean sorghum without broken grains and mold growth. Wash thoroughly and half cook this grain. The grain must crack but should not open like this. Drain the water and spread it for 4 hours for cooling. Then, mix 15% chalk powder and 10% gypsum on dry weight basis of the grain. This is to keep the individual grains separate and to balance the pH. Then fill the grains in PP bags of 200 gauge. Keep a cotton plug in the neck and tie firmly. Then, keep the bags in the autoclave for sterilization for 2 hours at 120 pound pressure. The bags are then taken out and kept for 4 hours for cooling. Bag should not be opened for any reason. Inoculate the fungal culture into this bag after it cools down completely. Perform this work above the spirit lamp in the inoculation chamber. Tie the bag again and keep it in the dark room for 10 to 12 days. By then, the fungal mycelium grows and covers the whole mass of grains. Check the spawn bags individually for any contaminant growth. Destroy the spawn like this, by burning or by burying in the soil. Clean spawn of this kind is ready for use. Use the fresh spawn only. It may be kept for a week in the refrigerator. The old spawn will yield less. Use the entire spawn bag after once it is opened. Government labs produce the spawn in the saline bottles or PP bags. They sell this 250 gram spawn for 10 rupees. But for commercial cultivation, a spawn bag of half or 1 kilogram is comfortable. Spawn costs around 35 to 40 rupees per kilogram in large-scale production. It is better for the common farmer to purchase the spawn from responsible labs. Now we have reached the main part of mushroom cultivation. Bag and cylinder systems are the two types followed commonly. Government departments and hobby farmers follow this bag system. Here the substrate is filled in a small poly bag of 1 feet diameter and 1.5 feet height. But for large-scale production, the cylinder system is better. Of course, the principles and the methods are same in both the systems. This film explains the cylinder system of oyster mushroom cultivation. Select a cool and clean place for the construction of the shed for mushroom, away from the busy roads. A small shed or a room is sufficient for hobby growers. Here, the farmer is using the shed built for broiler chicks. In case of tile or sheet roofing, let the center height of the building be 15 feet and 10 feet on the sides. This height is necessary to avoid excess heat during summer. Thatched roof of this type is better. Trees around the shed keep the atmosphere cool. Mushroom shed needs good ventilation and light penetration. Here the windows are big and are fitted with insect-proof net. Gunny bags on the wall control the light and the humidity inside. Mud flooring is better. It absorbs excess water, reducing the chance of contamination. Otherwise, put a layer of sand of 3 inches thickness on the floor. This holds the water in between, which improves the humidity. The shed is 22 feet wide and 140 feet long. 10 cylinders are placed in each row widthwise. A gap of 1 foot is maintained between the cylinder to facilitate the growth of the mushrooms. Between the two rows, 2.5 feet of space is left for the movement of the workers. This shed accommodates around 400 cylinders. The cylinders are placed on bricks to give air gap at the bottom. Hence, the end of the central pipe keeps open. Here, every day one fresh row is being added. This plan of continuous batches is to get regular harvest of mushroom every day. It is difficult to maintain humidity in this big shed. Harvesting starts on one side of the shed when the spawning continues on the other side. So the control on the contamination becomes difficult. It is better to divide this house on lengthwise in 2 or 3 clear partitions. Visitors should not be allowed inside the shed unnecessarily. Remove footwear and soak feet in the disinfectant solution compulsorily when entering the mushroom shed. Scientists recommend 2 separate sheds for spawn running stage and mushroom crop. This is to avoid the chance of contamination. If so, the individual cylinder should have a stand so as to make it movable. This metal stand works out costly. Shifting this heavy cylinder is also difficult. To avoid all these, make small partitions in the shed. See that the spawning batches complete in that shed in 30 days. Then, continue the further batches in the next room. Clean the shed before starting the crop. Here, the walls are given whitewash and the floor is cleaned by scraping. Take 5 ml of formalin, 1 ml of dichlorvus insecticide and 1 gram of bavastine and mix them in 1 liter of water separately. Spray these solutions separately to the floor, wall and roof thoroughly. Spraying is carried out twice a week for 4 weeks. Give a gap of 2 weeks after the completion of the crop and take up the cleaning work in the same manner. Now we have come to the main step, the spawning. Oyster mushroom can be cultivated on the straws of paddy, ragi, wheat, coffee husk, sugarcane trash, etc. But the paddy straw is a common and the best substrate. Select the hard and clean dried paddy straw. Very smooth straw of this kind will hold more water, leading to the decay. Let the straw be new without any fungal or mold growth. Otherwise, it will act as a source of contamination. It is easy to chaff the hard straw. It is good for the spreading of the fungal mycelium also. Chaff the straw for 2 inches length. Soak the same in clean water for 5 to 6 hours. Drain the water and fill the straw in the boiler. Boil it for 1 hour at 80 degrees centigrade temperature. This is pasteurization method to kill the contaminant microorganisms. Chemical pasteurization is also in practice, but it is not recommended here since it has some problems. Take out the straw from the boiler and drain the excess water. Spread it on the clean floor, preferably in a closed place. But this farmer dries it under the sun for 1 hour so as to retain 60% of moisture. That means the water should not come out when it is squeezed like this. If the water content is more, it trickles down like this. More moisture hinders the growth of fungal mycelia, leading to the decay of the substrate. Maintain absolute cleanliness from pasteurization to the spawning stage. If the dust sits again, the very purpose of sterilization fails. This is most important for the control of contamination and hence the success of the crop. Next step is spawning or mixing the fungal spores with the straw. Take a plastic tube of 80 gauge thickness, 16 or 20 inches diameter and 7 feet in length. Take a 7-foot long PVC pipe of 2 inches diameter. Drill 10 mm holes to the entire length at the rate of 2 holes at 3 inches gap. This pipe and the holes are necessary for the release of heat and the gases from the substrate in the spawn running stage. Otherwise, the straw will decompose. Still bigger pipe with more number of holes is better. A bamboo stick covered with plastic is provided for the support of the cylinder. Fold the plastic tube and tie the lower end tightly, keeping the pipe at the center. Put 2 or 3 bricks at the bottom so that the cylinder and the pipe do not touch the ground. The people doing this job of spawning must wash their hands and apply spirit. Person putting the spawn should not touch the straw and vice versa. Pasteurized and cooled straw is put in a layer of 2 inches. Then the spawn is spread. Again a layer of straw. Repeat the same till the cylinder reaches 6 feet height. This needs around 2 to 3 kilograms of spawn. Recommended quantity of spawn is 3 to 5% of the dry weight of the straw. Let there be the spawn layer at the top. Tie the plastic tube tightly at the top, keeping the end of the pipe open. Plug both the ends of the pipe with non-absorbent cotton. This is to prevent the entry of insects inside. Fungal mycelium develops and covers the entire substrate of the cylinder in 15 to 20 days. This is called spawn running stage. 25 to 30 degrees centigrade temperature is good for this stage. Ventilation and light are not necessary. Fungal growth comes down if the temperature exceeds 35 degrees centigrade. Since the fungus grows inside the plastic cover, the outside humidity has no influence on it. Check the cylinders for any contamination. See, this bed has some unwanted growth. If the contamination is severe, take the entire cylinder out from the shed and destroy at a distance. Continue the spraying of chemicals twice a week. Close the holes in the plastic of the cylinder if any. Cut open the plastic after mycelium covers the entire straw bed. Then maintain 25 to 30 degrees centigrade temperature and 70 to 80% relative humidity. Spray the water on the gunny bags on the walls to maintain high humidity. Spray the fungicide and insecticide twice a week everywhere except on the beds. Strictly avoid the spray touching the open bed. Filtered light and clean air are necessary at this stage for the growth of the pinheads of the mushroom. Otherwise, the concentration of the carbon dioxide increases, suppressing the growth of the mushroom. Sprinkle clean water 2 to 3 times a day on the open beds. However, excess watering is not good. Fogging system at the top is better. Put insect-proof net on the windows and doors to avoid the entry of mosquitoes and flies, etc. This is the mold growth on the bed. Destroy this contaminant spot by soaking with 4% formalin solution with the help of a cotton. Mushroom pinheads start growing in groups after 2 to 3 days of opening the plastic. It takes 7 to 8 days to grow into full size. Harvest before it releases dust-like spores from the gills. Otherwise, the shelf life comes down. Pluck the bunch of mushroom with the base itself by twisting. Otherwise, the base decays, attracting contamination. Stop watering the beds 1 day before harvesting for easy plucking. After completion of the first harvest, scrape the surface of the bed with metal wire brush. Keep on watering the beds. Second crop gets ready after 7 to 8 days. We can expect 3 crops like this. The straw bed shrinks down. Commercial harvest completes by 50 days after spawning. Each cylinder of this size yields 15 to 20 kilograms of mushroom under ideal condition. Mushroom yield depends on the species, purity of the spawn, contamination-free mycelium growth, temperature and humidity at the time of cropping, etc. Clean the plucked mushrooms. Polythene packets with holes are used for packing. Keep the packets in a cool place or in the refrigerator. Continuous crop will help for easy marketing of fresh mushrooms. It can be dried under the open sun or in a dryer. If the dried mushroom is clean and white, it gets good demand and price. Tasty pickle is also made with this fresh wet mushroom. What we have seen till now is Hypsizygus ulmaris species. This keeps good for 3 days in open cool place and for 1 week in the refrigerator. Shelf life of the other oyster species is hardly 1 or 2 days. Do not throw the spent substrate as it is. It leads to the multiplication of insects and contaminant fungi. This will pollute the whole premises and troubles the next crop. Hence, spray the spent bed of straw with 4% formalin, 0.1% bavistine and 0.1% Nuvan separately. After 1 or 2 days of spraying, take out the bed from the shed and use it for manure production. Then clean the mushroom shed and spray the disinfectant as usual. You may start the fresh batch after 2 weeks. Let us repeat some important points. The straw used for the cultivation should be free from fungal growth. Since the straw itself is the main source of contamination, keep its storage away from the mushroom shed. The person chaffing the straw should not enter the shed. Do not allow the visitors in the mushroom house. Maintain optimum moisture content in the substrate. Take care of cleanliness while spawning. Do not miss the sprays of fungicide and insecticide in the shed. Maintain optimum temperature and humidity in the growth room. Mushroom cultivation is a sensitive and technical job. Do not search for the shortcuts for any of the steps or methods discussed in this film. Successful mushroom crop will certainly bring bumper profits. The farmers who failed till today have not followed most of these procedures and precautions. Maximum cost of production of the fresh mushroom is 20 rupees per kilogram. Present market rate for this fresh oyster mushroom is at least 60 rupees per kilogram. There is no problem of marketing if the supply is regular. If you are able to control the contamination, your success is assured.